I'm going to show you two ways to answer the following question. Is x plus 2 a factor of x to the fourth minus 5x squared plus 4x plus 12? Your first option is you can divide. I would recommend using synthetic division just because it's a lot quicker. So I'm going to demonstrate how to do synthetic division. I've already done it in a few videos. If you can do it on your own, I recommend that you pause the video and try it on your own first before you watch me do it. But because I'm dividing by x plus 2, I'm going to put -2 in the box. And now I'm going to bring down all of my coefficients. However, I'm missing an x cubed in my polynomial, so I'm going to fill that in with a 0. So because I went from x to the fourth to minus 5x squared, I need to put a 0 in between because there should be an x to the third, but since I don't have one, I need to put a 0. You can't divide unless you have all of those exponents present, and it needs to be in standard form. This one luckily was already in standard form for us. Now I'm going to bring down the 1. You always bring down that first term no matter what it is. Now you multiply that number by the number in the box, which is -2. Now I add, and now we start over. This -2 that I just got is multiplied by the -2 in the box, which is +4. Now I add that to -5 in the next column. I get -5, and I just keep going. Multiply. I think I just said something wrong. -5 and 4 would be -1. I feel like I just misspoke. Anyway, we get -1. That is what's multiplied by the number in the box, which is -2. That's a +2. Add down the column, you get +6. Multiply by the number in the box, we get -12. Add, and we get 0. Now, I wrote right on here, if there is a remainder, then it is not a factor. Because I got a remainder of 0, we say that x plus 2 is a factor. Sorry, I keep misspeaking in this video. Okay, so I divided. I got a remainder of 0. When you get a remainder of 0, that means it must go in evenly. So that means x plus 2 is a factor. Now, your other option is to use the remainder theorem, so I will demonstrate that. To use the remainder theorem, you take whatever number you would have put in the box for synthetic division, and you just plug it into your polynomial. So because I'm dividing by x plus 2, I'm going to take -2 and plug it in for every x in that polynomial. So right here, I've replaced all of my x's with -2. Your first step in the order of operations would be to simplify the exponents. -2 to the fourth power is +16. -2 squared is +4. Now that I've got rid of my exponents, I can multiply. -5 times 4 is -20. 4 times -2 is -8. And now I just combine these numbers, add and subtract. And I should get the same remainder that I just got with synthetic division. So because there is no remainder, I would say yes, x plus 2 is a factor of that polynomial that we were given. So the remainder theorem spits out the remainder for you. You plug in that number, you get out the remainder. So again, you can use either option, but if you're specifically asked to use the remainder theorem, this is how you would do it. If you aren't told to use the remainder theorem, you always have that option of using synthetic division.